So 1 second here. All right. Thanks everybody for joining. I know that as this goes, more people will come and go as the call goes on. So we are recording this and live streaming it to YouTube. All of the content for this recording after the fact can be found on wwt.com. I will drop a link in the chat at some point to where those recordings will be posted. So if you want to either watch it again or have to drop and want to consume the content later, you can do that. We'll also post the presentation out there. So this is the kind of first in a series of talks as it relates to infrastructure test automation. So with that, I'm going to turn it over to Tafsir, who is going to kind of give us a rundown of what his plan is as far as the series of conversation go, and then we can get into it for this week. If anybody has any questions, either come off of mute. If you don't want to come off of mute, drop it in the chat. We'll queue them up. We'll get them answered that way. But the goal is to keep this interactive. And if anybody has any feedback or anything like that, or even wants to present on a topic at a future date, please let us know. So with that, over to you, Tafsir.
Hey, yeah, so I think as you mentioned, what some of the conversations we're really having is around the fact that obviously automation, right, especially like network automation, is centered a lot around configuration automation. And so with uh, a lot of demand that we see usually around test automation, we wanted to sort of expand conversation to allow us to talk about what that looks like, what are the frameworks, concepts around testing in general. And so what we're planning on doing is going through a series of meetups where we look at different frameworks, maybe lay out different concepts, right? So today we'll be looking at testing and validating networks with Pytest, but even this will be part one of Pytest, right? As you'll see, there's a lot to Pytest, and it actually lays it lays the groundwork for a lot of subsequent talks that we can have, some especially around things that are in the Pytest ecosystem, right? Like test infra, if you've used that. But I'm sure you probably want to know. Um, 1 second. Who is this you're talking to? So, who am I? I'm Tafsir, obviously. I live right outside of New York City in a town called Montclair, and I currently work as a senior automation consultant at WWT. And probably also want to know why you should listen to me, right? And the thing is that I'm very passionate about this topic of testing because I've led a lot of our automation engagements in general, and testing has always been a key to any successful effort that we've embarked upon, right? It is very common, like I said before, to see lots of teams who are well on their way to do automation. And along that journey, it's still rare for me, at least, to see teams who have gotten to a decent comfort level with when it comes to testing, right? And the reality, at least from like my vantage point, is that there's a lot less content around testing, especially testing with regards to infrastructure, than there is around, getting started in automation, right? Um, so, um, anyway, like I originally picked up Python as during school projects in grad school around the 2012, 2013. I put it down for a while, and now I've been using Python for profit, I guess, since about 2015. I think the very first time I had a real use case was, when I was at a large army base, a deployment had already gone, and I came in looking to document the network, and it was a very, very large campus. I had to walk around and find all of the APs and all of the device information because that wasn't documented. And so I figured out it may be high time to dust off some of that Python I had put down, and I actually found some very hacky stuff online that I was able to customize to do what I need, and I've been writing bad Python since. Um, so That's about me. I guess the other thing that might be interesting to talk about is why is testing network infrastructure a discussion worth having, right? If you've started your career like I did as a network engineer, you learn to appreciate that there's really no such thing as a small change to a large system, right? Any small change can have impacts that linger well past whatever change window you have, right? And what you end up seeing is organizations that grow tons of technical debt just because maybe the change management now is too rigid. But that's usually in response to failed changes, right? And failed changes that over time sort of build up, right? And the folks outside of your domain sort of maybe lose a little bit of trust. And so I think for me, right, validating the intended state of your network is probably far more important than like any automation that you can accomplish within your deployments, right? Because the reality is when you trust your automation, you can move fast. You can move fast and know that maybe you're not breaking as many things, right? So what are we doing when we're testing network infrastructure? I think ideally we're trying to validate that some deployed state matches well what our intended design is, matches probably more importantly, what the customer, the end users expect, right? The behavior of the network to be. We want to be able to obviously do pre and post sanity checks right before any event. So want to make sure that we sanity check some of the data, sanity check the environment, right? Or capture maybe some output so we can replay those same sanity checks at the end. And probably a use case that I see a lot, maybe in the larger customers for me, is the idea of certifying designs, or maybe certifying that certain designs would work at when you throw scale at it, right? So you're bringing in a new platform with a new OS maybe. How does that um, combination work when we throw some scale at it, right? Is it going to be able to is it going to be able to sustain like the intended design that we have for it? I usually see that in our more of our global customers and the ISPs. But I think that's probably a use case for everyone, right? Verifying that there are no regressions when you're bringing in a new operating system, verifying that again, maybe your new EVPN VXLAN fabric works as intended. But ultimately, it's, your testing is there to provide safety and build trust for your automation, right? Because if you're going to move fast, that's essentially what you'll need. So maybe it'd be interesting to know, is anyone on the call doing any testing, or maybe specifically testing with Pytest today? Has anyone used Pytest at all?
Yes.
Yes. Nice. Uh, so maybe when I trip up, you can help me. But yeah, so sometimes I think what you'll find is there's a lot of content around PyTest, the use of PyTest for testing software, right? But not necessarily for networks. And we'll get into maybe while we're starting here. But before we get there, maybe what are some of the questions that you want your testing to when it comes to network infrastructure, right? What are some of the questions that you'd like to answer? These are just a few. Obviously, it's not just to kind of show some of the things that you may be interested in being able to answer, right? Like, am I able to communicate over, these are the kind of behaviors that you might want to verify, right? Am I able to communicate over this new VXLAN EVPN fabric I just deployed? Maybe I can communicate, but the top of rack switches receiving the default routes that we expect them to receive, right? So everything is working, but maybe there's only one default route. How do we sanity check those things and make sure that these are things that can be automated, so it's not a process that needs to be manually involved in order to uh, uh, make sure that we have the intended behavior for the long run. And then more of a sort of scale thing that I was describing, right? Are the device resources stable when we inject, let's say, a certain number of routes, right? That will be more of your sort of stability sort of use case when you're testing a design at scale. So in the network ecosystem, there are a lot of frameworks that there's starting to be a lot of frameworks that intend to help you do some of these things. Obviously, today we're starting with Pytest, and the reason is because um, you know, it's it doesn't have a domain specific language. It's Python, right? A lot of folks are starting with Python anyway. I think it's a good place to start. We'll discuss some general testing concepts and then use sort of Pytest to demonstrate those. But it also lays the groundwork for things like test infra, right? Because that's it's a Pytest plugin. And then it's a Pytest plugin, for example, that Molecule can work with, right? So there's some tie in there. And then Pytest is a Cisco library that provides a test framework. It provides a bunch of niceties around like parsing and learning things from devices that you can use. Uh, but generally, I find myself in conversations where I'm with customers and it's like, hey, what's the best framework to use, right? And I'm a professional services guy, so a lot of times we come into different environments, different working with different teams with different skill sets, and you may not always be you may not always have the choice of which framework to use, right? The environment may dictate it, maybe your project length. Like if it takes if it takes 3 months to get a framework in, and the project is 4 months, it's probably you're probably going to try to figure out like what else works, right? So I think what's been important for me is understanding like some of the concepts around testing that are portable across any of these frameworks, and then figure out how to do a proper test within these frameworks, right? But Robot Framework is one that I've used quite a lot, right? I've used Robot Framework with integrations with Pytest. You can use Pytest with Batfish, for example. Batfish will give you the ability to do testing without having to actually connect to devices. So you get a representation of your network, and then you can learn from that representation and be able to validate some of your assumptions, right? So then, really, why Pytest? Why would you want to consider Pytest? Um, I mean, the fact of the matter is, it's a very mature framework, right? It's been around since 2004. It came out of the PyPy, the PyPy project, which is a Python implementation that's sort of more interested with getting higher performance out of Python. And so they needed a very robust testing infrastructure, and so PyTest kind of came out of that. And it provides a ton of features, right? A ton of features that help your user experience as you're testing, but also helps you to write better tests. It has an automated discovery feature, right? It allows you to write, especially compared to other test frameworks. So for example, unit test is part of the standard library of Python. And compared to unit test, you're able to write tests that have little to no boilerplate at all, right? And it gives you very good feedback when things fail. And then again, the ability to write good tests, and maybe we'll discuss what those are, right? Using some of the advanced features that it provides. And if you need to enrich your experience or maybe customize things, right? It's got a very rich plugin system that's got a large ecosystem of probably over 1,000 now of plugins, right? And then you can customize even locally to sort of improve your experience and get more capabilities. So what do I mean by boilerplate? On the left side is the example that I pulled on probably 90% of it right off of the documentation for unit test. And you can see that it's essentially it's an XUnit uh, style testing framework, right? Where it's class-based, you subclass this thing, and then it provides you with methods that allow you to assert certain things. You can see that In fact, well, you can't see, you can only see a few of these: assert equal, assert true. There's literally a very, very long list of like these helpful assert methods that you can use. Well, in Pytest, one of the greatest features is actually how it uses the assert statement, right? It's just assert. And under the hood, what Pytest does is sort of um, made some changes to how assert works so that it can introspect your objects and provide a meaningful, a rich and meaningful feedback when things fail, right? And we'll see some examples of what that looks like. But from a boilerplate perspective, you can see I'm not importing anything, right? I'm literally just defining my functions and I'm doing a simple assert, and it just kind of works, right? And out of the box, it'll actually run, as you can see, it'll actually run unit tests and those test suites without any additional configuration. So, how do you get started with PyTest? Well, it's uh, it's it's distributed through PyPI, so it's a simple pip install, right? And what it is primarily is basically a command line tool that allows you to invoke test. And it allows you to do that in a number of different ways, right? You can say PyTest and then give it the name of a file. You can give it the name of a path, um, or you can just say PyTest, in which case what will happen is that auto discovery feature that I was referring to, right? And the way that that works is that PyTest will actually go into it'll start from either your current working directory, or if you've configured a test path directory, it'll start from there, and it'll recurse into subdirectories and try to find tests that match this pattern that you see, right? So it'll discover any file or module, right, that starts with test underscore whatever py, and or that ends in whatever underscore test.py, right? And within those files or modules, it will attempt to discover test functions that start with test underscore, or classes that are prefixed with the test. And then within those classes, also obviously any method that starts with test underscore. And again, you can see that it'll discover like unit test cases. Any questions so far? Before, I know I'm moving a little fast because um, and this is a little bit of an irresponsible introduction to PyTest. Obviously, if we were to go down to the entire list of what you can do with PyTest and what it is, I'll be regurgitating the official documentation. But any questions that I can help answer right now before we keep moving? Yeah. All right. So what I mean by the useful feedback that it gives you, right? Again, PyTest uses just the assert statement, right? But when it fails, when your test cases fail, it can do things like, if you see the string here, right, where I'm expecting presented by Tafsir to be presented by Tafsir, it gives me a little caret sign and tells me exactly where that error is. This is not a behavior that you get with when you run the assert statement just with Python. And then you can see here, for example, we're testing our this is a typical test case for PyTest, where we're testing a function that we've written. And in this case, we're expecting that the value is, the addition of the numbers that we pass it, and it tells you how you got to this 3 is because we passed it to a function, and here it didn't pass, right? But another important useful feature that PyTest reports is the possible outcomes, right? It's not just a pass and fail, right? A test case can either pass, it can fail, it can be skipped. You can X fail. This is when you expect a condition to fail. Usually, so I struggled with this when I was writing, a little bit when I was writing tests for actual code that I needed to test, right? But from an infrastructure perspective, like imagine, for example, you're testing a scenario where on spines, you don't expect VLANs to be declared, right? And then so you have this test that will test your entire infrastructure to see whether or not VLANs are defined the way that it should be defined. Well, if it comes to the spines, you can have that be an expected failure, right? We expect that this test will fail against spines, and if it does pass, that's probably problematic for us because we don't want VLANs defined there, right? So that's probably that's an example, for example, where I found that to be useful, and obviously XPath is a pass that was meant to fail, right? And another very useful thing that saved me quite a bit is the error. So errors happen when there's a failure, but really a failure outside of your test case. So this is maybe in the setup of your task. So in things like a hook or fixture, and we'll talk a little bit about what those are. But again, the idea is there's a number of ways that tests are reported, and Pytest you generally tries to be very helpful in helping you out when you get failures. So I said that, generally it's not a class-based thing, but you can actually use classes in Pytest. Obviously we talked about the auto discovery, right? You can use classes in Pytest to group your tests. And if you're familiar with OOP concepts, you may be familiar with like concept of inheritance, and you may say, oh yeah, I could probably define a bunch of helper functions and do a lot of stuff. I think primarily it's probably best to keep these more for grouping, because if you write very complicated tests, they can, especially like with different skill sets on the team, right? They can kind of be hard. If you get too fancy, right, they can be you can confuse others, or maybe even your future self, right? If you're not too careful and you go overboard with that. But speaking of grouping tests, right? One of the benefits that you get, obviously, is you can now run a subset of tests, right? And Python and PyTest gives you a number of ways to do that, with some of which are laid out here, right? So if you have a test group, just like we saw, right, where you have a class, and let's say that in that class you just wanted to run one of those tests. So for example, in here, I want to just run the test upper test case, right? And the way I would do that then is call Pytest and then provide the path. This is the path to the module. This is the actual file, right? This is the class in that module. And then this is the test function, right? And obviously, if I wanted to run everything in that test function, I would just sort of drop the specificity here at the end. And then for modules that only have test functions where you don't have them group in a class, then you just sort of reference the test function right there. Obviously, if you want to run the entire module or the entire file, you'll do this, and you can again run all the tests in a directory, right? But probably more important is you can find tests, you can collect tests using a pattern, right? So you could say -k and then provide it, I don't know if it's regex, it's more of a glob like sort of pattern where you can say, find any tests that have str in it, right? Or any test, even because this is just, it's not just in the module, right? You can find any test that has upper within the name, right? So you just type upper here. And related to this is the concept of using markers, and we'll talk a little bit more about what markers are. They're basically, generally, they're just a way to sort of signify that there's something a little bit important about this test case that you're doing, so you can mark it. And obviously that makes it easy to run a subset of tests, right? So if you have smoke tests, for example, or if you have tests dedicated to the underlay of your infrastructure, then you can call those. And again, if you run pytest-help, you will get a ton of options. I mean, it's literally a ton of options, right? But some of the ones that I find myself using a lot are the common ones are those that you see here. And maybe what I'll do, we check some of this out. So let's break out and do a little bit of coding so we can, well, not coding, we can see some of this output looks like. Are you guys able to see my screen when I do it like this? Are you able to see my? Sure. Yep. All right. So again, like I can run just Pytest, right? This is going to go and find all the tests to run. It's collecting a bunch of stuff. I'm on the wrong branch here. Let me switch to another branch. Oh, anyway, it's okay. So you can see the output of tests that ran, right? We were doing a bunch of stuff, and I ran this. Yeah, this is the switch. Let's switch branches real quick. I have a So the output that you saw was a verbose output. And the reason you actually saw this without me typing is because I have the verbose output in the file here. We'll talk about this configuration file here. But the verbose output is what you saw, right? When I ran that, it gives me a lot of information. So if I were to take this out, you'll see. By test. Out of the box, this is the sort of output that you'll see. E again is error, because remember we were looking at the different outcomes. You will see F for fail. And then the ones that pass, you'll just sort of see dots, right? These green dots are testing tests that are passing. So in here, for example, if we look at what we were saying, we could do Pytest -v and we'll say -k. And let's try upper. And now you see that this time 21 tests were deselected. They were found, but they were deselected, and then the 6 that we wanted to see passed, right? And then we'll come back to this here in a little bit. I'll stash that for now. But you can really change your user experience based on a lot of these flags. The PDB, for example, if you have a failure in your test, you can launch into the Python debugger and then look at some of the values and then sort of double check some of your assumptions, right? But before we start going into the actual Pytest features, and we'll do that in a bit, I think it's interesting to talk about what the anatomy of a test looks like, right? And what are good patterns for writing tests. Certainly a popular one is the AAA, the arrange act assert pattern, which was popularized as part of the TDD practice, right? And really what it is a method of methods of separating tests into stages that allow you to focus on each part, and then and that way you know exactly what you're testing, right? So the arrange step, this is sort of like getting ready to do a test, right? All the things that you need to do that. The act is hopefully the singular action, right? That kicks off the sort of behavior that you want to validate, right? The behavior or the state that you want to validate for our purposes in the infrastructure, right? This is sending a show command to a device, right? Getting the output of that show command. And then the assert stage is this is where you check whether things worked the way that you expect them to work. And obviously not part of the AAA, but an important step in writing your test is considering cleanup, right? Because what happens is if you have a lot of tests, you want to make sure that you're not influencing tests that are downstream, right? By changing state that will break those tests, right? So we want to make sure that the test cleans up after itself. And whether you're doing this or you're doing something like the give, when, then, which is popular, I think, in the like Gherkin syntax, as part of like the behavior driven practice, right? I think it's the same thing, right? You want to be able to make sure that you're avoiding the anti-pattern where you're doing a bunch of arrange, assert, acts, or assert. You have all these statements that are, doing things and then asserting and doing things and asserting, right? Because what happens is at some point you don't know what you're testing, right? Because you have all these steps. Ideally, your test cases should be able to validate a single behavior, right? And the test almost becomes a documentation for that behavior that we're testing and validating, right? And a easy way to remember to kind of not follow those anti-patterns is maybe to keep your assertions at the end of the test. Obviously, it's not always possible to keep, one assert statements, but minimize them, right? If you're obviously doing something like I'm checking the IP address and a mask, and I need to make sure that both, yeah, in that case they're related. If I need to do two assert statements there, that's okay. But like, because they're related, right? So just something to keep in mind, and something to keep in mind when we start looking at tests and when we start to look at some of these examples that I'll show.
Hey, Tafsir,
Hey.
are you going to show an example? Like you had a test there where you had like a leaf switch or core switch, and you mentioned about doing show commands. Do you have
Yeah,
an example in your repository there
I do.
are you going to go over that or?
I am. So Pytest is like this. I think there's an overlap of like simplicity and magic. So I just want to make sure that I cover some of these things that may seem magic right before we get into that.
Okay.
So some of these, obviously we talked about markers, what you can do with those. You can mark your test. Like, so for example, I could say, this is an underlaid test, right? And then I can select my test based on this marker. As long as I register it, right? This is a custom marker. But probably more important to our discussion today are the built-in markers that Pytest provides you. One of which is the parametrize, and this is one that we're going to look at. Skip, obviously, if you want to skip a test. Skip if you want to skip on a condition. So for example, if this is a Windows platform or whatever kind of platform that you can reason about, like as you're gathering data, you can skip it. And then the exfil that we talked about, right? This is an expected failure. These are things that you can use as decorators on your function. So the other thing that we're going to talk about, and parameterization, is one that that again can be provided by one of those markers, right? So this is a built-in marker that you can use. There's multiple ways of using parameterize, but one way is to use a marker. And parameterization is one of these useful features that allow you to write good tests, right? So in this case, you see we have a bunch of repeated tests, right? That are really the same test case, but with different data, right? And so what you can do is you can have a single test that provides multiple sets of arguments that you can go through and you can test them, and you still end up with the benefit of having multiple test cases. So even though it's a test function, right? You can see at the bottom here the output. You'll end up with multiple test cases, one for each of the test inputs that you're providing. This is very important because as network engineers, you start thinking about, oh, I have multiple devices here. When we connect to them, I'm probably going to do these for loops. And usually what happens with that is, one of the elements in your for loops fails, and then the entire test case fails, and anything else, in that list of elements that you're testing against is not tested, right? This way of doing things ensures that you have a test case for each input, and each one is tested independently. So if you have a lot of interfaces, for example, you have a lot of devices, this is a pattern that'll be that helps a lot with that. And then the other thing that is this is probably like the superpower of of Pytest is the idea of having fixtures. And fixtures are probably the most magic of things, like if you're new to it, because they're the ones that give me the hardest thing to wrap my head around, but they tend to be like the simplest thing, right? So fixtures are used typically in the arrange steps. So we talk about all these different steps, right? Arrange steps to provide dependencies to your test functions, right? To provide data to your functions, for example. And they help with cleanup too. So this is the example that you see from like the PyTest documentation, right? So you have this fruit class, and then your fixture then can you can define a fixture, which is really just a function that PyTest calls before your test. So we have a test case right here, right? And you see we define my fruit right here. What this means is that we have a dependency on my fruit. So before this test runs, PyTest will run this function and return its value, right? So in this case, we're returning an object that's a fruit and it's an apple, right? And then you can actually pass this fixture to another fixture, right? In this case, we have a fruit basket to which we're adding that initial fruit that we created, right? And then creating a new fixture. And in fact, you can reuse the test, right? Because then you'll have this fruit basket that has both your fruit and the new fruit, and you can also still have access to that original fruit. Yes, it's a mouthful. What that means to you as a network guy is you can do some pretty neat setup using a fixture, right? So if you think about like the data that you have for a device, right? So let's say you have device data here represented, like you have a host data, you have username, password, and the type of device. Well, what I can do is I can create a fixture that allows me to do setup and teardown. And fixtures have a very neat syntax for that. And the way that that works is anything essentially above this yield statement happens as part of your setup. Anything below it happens as part of your teardown. So now when my test function calls as a dependency this connected device, right, which is our fixture here, well, what'll happen is I'll get my connected device, and then whenever this test function is done, and by default, this fixture is scoped at a function level, right? So whenever the function is done, then my teardown would automatically be executed, right? So in this case, I'll disconnect the SSH connection. And so this is one of those examples, Joel, where you have we're sending some show commands, but let's break out of here, and then let's so so we have some simple tests here, right? And this is probably like a bunch of bad things that you probably shouldn't do. But we'll start here, right? So these are some examples of like what, you may start thinking you can do, right? You bring in whatever in this case, we're going to use NetMiko to connect to these devices. So what I'll do then is, hey, I want to ensure that BGP is enabled. So how would I do that? I have a device file that's got some connection details in them. And then what I'm going to do then is read in that file and then loop through the devices in that file and connect to them and, test something. This is that pattern, for example, that's sort of that anti-pattern, but it doesn't look that way, right? Because, well, I'm just doing one for loop. Well, for each of these devices, right, I'm testing something, but if any of these devices fails, then the rest of the devices are not getting tested at all, right? And so Let's see if we can run this guy. So you see, I'm failing assertions here. I went to the device. I'm checking to see if VLAN. So this is the list of VLANs that I have, right? The very first VLAN is 4093. As soon as I start my test, I realize that there's only VLAN 1 defined on that list, but I don't get to test the rest of these VLANs because in that for loop it stopped and my entire test case failed, right? And so again, this is that sort of NT pattern I was describing, right? And so the way that parametrization can help you with that is you can say, okay, well, we'll take that list of devices, right? And then we'll use our marker here. This is our built-in parameterized marker, right? And we'll supply that list of devices to this parameterized function. And what it'll do is for each of these devices in here, we'll inject the dependency into our test, right? And so when we inject the dependency into our test, obviously it's useful to be able to ID like each step. So for the IDs, we're saying, hey, just pull out the host name for the device and then display that when you run this test, right? So we know which device we're running against. This is slightly improved, but again, it's another one of these bad tests. So let's do this. And I left these devices not configured on purpose so we can play around with these, right? So now you see what the output, and I don't know if you caught this before, right? So now you see that I have for each of these, let's go see what the, so in the old output, I got these two failures, right? Now I have four test cases, right? One for each device and one for each test case. But this is the ID that we're selecting here, right? So when you parameterize a test, this and then you pass it a list of IDs, this is what is shown so you know exactly like which step you are. So we're running, in this case, we're running the test enable test function for leaf 1A and then for leaf 1B. And then again, we're doing the VLANs exist for leaf 1A and for leaf 1B. But the VLANs still fail, right? The assertion because well, we're still doing this for loop thing, right? So for each VLAN, it fails again because we're doing that anti-pattern again, right? We're doing act, assert, act, assert multiple times, even though it doesn't look that way. I only have one act here and one assert, but we're doing that multiple times because it is for loop. So how do we do that? Well, Python actually allows you to stack parameterizations. So in this case, now we're saying, okay, we'll remove the for loops. This is still a bad test, but we'll remove the for loops, right? So now you don't see any for loops here. What we'll do is we'll inject dependencies for both the device and the VLAN. So for each of these devices, we'll inject the dependency for each of the VLANs, and then we can test, right? So then if we do this one, this is the still fails. Obviously, the devices are not configured. And these devices, by the way, they're I'm using container labs to provide the devices in this infrastructure. So these are just running as containers on my machine. Um, just in case you were wondering where these devices were. Okay, so now what do we have? Now we have a bunch of tests, right? Now we have 12 tests. And you can see that, you know, we have our two tests for the BGP enabled. And for each of the VLANs, right, you can see for leaf 1, I have VLAN 4093, 4094, 110, 111. And then for leaf B, again, each of these. So then what we can do, like, just to see if, let's see if we can actually, let's do this. Let's go, create container. I like to do this to myself, so let's do it live. Let's go, which device? We're doing leaf 1A, so let's find leaf 1A. We'll connect to the container and manually configure this. So we'll go in, we'll create VLAN. Which VLAN do we want to create? We'll create VLAN 4093. We'll get out of this container, and then let's rerun this test again. We have our failures and we have a little dot there, right? For one of something passed, right? Obviously we can see a better output if we, let's run this in verbose. It'll be a little bit easier to see. So BGP again, we're failing, but now VLAN 4093, look at that, right? For VLAN 4093 for this particular device, we're getting the output that we want. So if you're troubleshooting and you need to know there's a number of things that are wrong, right? It may just be that a few of them are not behaving the way that you intend them to behave, but that gives you some context as to like where you start your troubleshooting, right? Because the last thing you want to end up, the last situation you want to end up finding yourself in is where you're now having to like write test for your test. Wait, is it the test? Is it me? Right? But again, I said that this was slightly improved, but not maybe that much. So now, because you can see, right, we're still reusing like this connect handler, like a lot of boilerplate, right? And we talked a little bit about fixtures. So what does a fixture provide me, right? In this case, you remember we said that we can use it for setup and teardown. So now this is our BGP this is our BGP test that's been a lot simplified, right? We're injecting our dependency again, which is provided by this fixture. And then for this test, what we're going to do, our act phase is to run a show command on the device, and then we'll check to make sure that BGP is not disabled. And then for our VLANs, again, we'll go ahead and in this case, we're combining like the fixture and the parametrize. We'll pass our device and our VLANs, and then we'll check to make sure that for each of our VLANs, right, we're having we have the expected output. But now you see like a lot of we've essentially factored out like that whole connection thing, right? From what we were doing here out to a fixture that would take care of the the setup and teardown. And I'll show you one thing we can do additionally on top of this. But let's run this really quick. So we'll do what do I call it? Oh, 6. So again, at this point, I should probably test that BGP is disabled so we can see it passing. But the devices are not configured, so they're failing. But I figured this would give us a lot to talk about. So now you see we get the same exact output, but it's cleaner. We can now start to factor this out of our test, and then Pytest actually gives you a way to factor these fixtures out even more, right? You can put them in configuration files. So Pytest has the concept of configuration files that allow you to group these hooks and fixtures, right? So that other test modules that rely on this fixture can use the same the same thing, right? And so now that we've taken it out of our test, right, and we've put it here, that's fine. But then now let's see what this will look like if we moved it out even further. No, 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 no. Modular test. So this is what a modular test will look like, right? In this case, now you don't see any of the setup stuff in here. So you see test, now it's just my test, right? So I have for this test, for this BGP enabled, I have my act set up, I have my assert, right? And then again, for my act, I'm going to have for the VLANs, whether just to verify whether the VLANs exist, I'm going out and running a show command. I'm checking this out without doing a for loop, right? So we can get multiple test cases. And I'm also doing here an additional test to see if MSTP is our spanning tree mode. Now, what happened to our, so this is where I meant by magic, right? So if someone who's new to the framework comes in, it's like, oh, well, how would this work? This device is here, but it's not defined anywhere in this module. Where does it come from? So again, Pytest gives you the ability to group your hooks, and hooks are ways to extend capabilities in Pytest, and your fixtures, right? So you can essentially have like they function as local plugins at that point, right? So now we have this conf test that py file, and maybe let's go back to a little bit of slides. So in Pytest, you can configure Pytest to using a number of different files, right? So one is this conf.test.py, which is essentially allows you to create to hold hooks and fixtures and any helpers that you need, right? And this can be you can define them in your root directory or subdirectories within your test. The other thing that I showed you by accident actually was the pytest.ini. This is more configurations for Pytest itself, like behavior of Pytest. Like you saw that I was able to pass a -v, for example. Any of those, so especially if you have very long set of things that you like to run at the command line, where you can kind of put all of those in your pytest.ini file, so it makes it easy. You can define like where your starting path is and stuff like that, right? And then also related to that is the contents of your pytest.ini. You can actually have them in different files. So tox.ini, if you're using the tox project, pyproject.toml, which is sort of the new way to do uh, packages in Python, and then the setup.config, right? So if you're already using those, you can define a section in those files and then provide your configuration. But going back here real quick, now if we enable this contest.py and then we go ahead and run this modular test, let's see what happens. Looks like we have a few more tests passing. So let me reduce the output that we get. So we can do TB because no, so this effectively oh, let me make that verbose as well. So again, these are the kind of things that you can sort of put in your pytest.ini to make things easy. But you can see now that our test spanning tree mode passed, right? So what are we doing again in that test? This is we're going to the device, and then we're sending a command. But at this time, you can see that I'm actually using a helper, right, to do this. So again, I factored out not only our setup, right, with the device fixture, but also I'm providing some helper functions that allow me to do things. And so why am I doing that, right? So if you think about it, like let's look at this test VLANs, right? Test VLANs, if we pass the VLAN fixture, right, for each of these devices, we're going to go to the device and run the show command. Well, it's the same output every time, right? But then for each VLAN, what I'm actually doing, I'm still going to the device. If I don't do anything, right, I'm still going to the device and getting the same output. And so one of the things I did here, for example, is to go and say, okay, well, I'm just going to wrap the send command, right, with a decorator. This is a decorator that provides caching. It's LRU cache is essentially like this. It's an eviction mechanism that releases the least used resource. So it'll cache. The way that the cache will work is if you call the same function with the exact same parameters, the output would get cached, right? So if I'm going to the same device and I'm providing the same command, well, it's probably going to be the same output, especially if it's something like show VLAN, right? So in this case, instead of going back out to the device, I would reuse that output from the cache, right? And so if you look at our modular test here, right? Now I'm able to use that from the helpers. So factoring all this out to your conf.test.py allows you to do things like this, right? And I realize that we're running out of time. This is why I said this would be sort of an irresponsible introduction to Pytest, because there's a lot of stuff to cover. This code, some of it is already on GitHub. The rest I'll add, and then we'll have a Pytest part 2 where we can get a little bit more in detail. But does anyone have any questions before? I know I went through very fast there.
This was awesome, man. Do you have any links or will this repo provide us
Yeah.
some practice?
Yeah, so I have links. Some of the resources so this Pytest that this thing lives on my desk. So that book is probably the best thing on Pytest that's helped me out. The Pytest official documentation is huge. Yeah, Jeff, I can give you the old version of it. Uh, but basically live by this book. It's very helpful. It helped me understand a lot of concepts. The PyTest official documentation is great. There's this talk on automated network ready for use. I think Jeremy Showman, I don't know if that's how you pronounce his name, but he did a great demo of how he's using this, and that's actually what got me thinking about like, oh well, yeah, PyTest. I'm already using it. Why not think about doing it for network testing, right? And then there's some great PyTest talks and tutorials again from the PyTest documentation. These are all awesome. And then the repo, obviously, I'll send that out. A lot of code in there, obviously some. Uh, uh, and I'll be adding to it, right? So by the time we get to uh, PyTest 2, we'll have a little bit more content to kind of go through. Any other questions?
Does Pytest have an integration with Ansible? In other words, is there a module for Ansible, or is there a plugin for Pytest? What does that look like, Tafsir?
Absolutely. So, and you remember in the beginning, I said that we want to lay the groundworks to make sure that like, when we get to other things, like they don't feel magic, right? So, test infra is a very popular, is a great library, is a great plugin, a PyTest plugin meant exactly for this use case, right? For infrastructure testing. And it has different backends. It has backends for like Docker, and one of the backends that it provides is Ansible, right? So you can use for your act phases of the test, for example, you can use Ansible to actually go act on the device, and then you can assert. And it gives you what it really gives you is like these fixtures, right, that you're able to use within your test. But again, like if you go into test infra, not understanding like fixtures, not understanding PyTest, it feels like all too magical. That's kind of why I thought like, this is probably a good place to start. And then when we get into PyTest version 2, maybe we might look at something specific to test infra, and maybe we could talk about robot framework. A lot of these things, I'm like the testing zealot around here, but a lot of these things are, you can see that, there's a lot of integrations, right?
Thank you.
So I know we're just about a minute over here right now. Thanks to Tafsir for the talk today. Looking forward to part 2. Like I said in the chat, all of the content from today, the presentation, a link to the repo, the recording, I'll get that posted right away as well. Can be found on wwt.com on the Programmability and Automation Meetup group community. So everything from today will be there and aggregated in one spot. And then with that, we'll wrap this up. I'll end the recording and the live stream. And if anybody has any other questions, please let us know. Otherwise, we're looking forward to having everybody back when we get the next one on the books here pretty quick.